Yes, in the beginning of the series, we will discuss the mechanical systems to be able to explain briefly, because everyone knows the fundamental laws of the mechanical systems from the physics courses. So, for example, we have a surface, and on the surface we have a single mass. And in our representations, we will use the wheels. If there's no friction, we will use only the circles. And if we have friction between the surface and mass, we will use crosses between them. But for the systems, we don't have any friction between mass and the surface. And this is our mass, and we will apply a force on the right side. So we will pull to the right. And on the left side, we have two components which are connected to the load, mass, and the wall. So these are spring and the dashboard. So after we apply the force, this component's effect will be obvious, and the system will tend to the right side. So according to our reference, we will move, our displacement will be x, and our speed will be v. So after that figure, which represents the physical system, we have to modify it, we have to simplify it by using an equivalent circuit. And we will call this equivalent circuit as free body diagram. So with the free body diagram, we will show all the forces on the mass with the arrows, and we will take into account the force's direction. For example, for the mass, we have, first of all, an applied force on the right side, according to our arrow of the applied force. Then, on the left side, after we apply this force to the mass, B and K, the dashboard and spring, will try to pull the mass to the left side because of their connection with the wall. So because of this, the reaction of the dashboard and the spring, their arrows must show this left side. They must be reverse direction with respect to applied force. In addition to that, we have to talk about the inertial force. So it is same with the other B and K, and it must show the left side also, because it will show any resistance to the applied force. So Fi shows the inertial force, Fb the force exerted by the dashboard, Fk which is the force exerted by the spring, and the Fa is the applied force. So what about their expressions? After we draw this free body diagram, we don't need anymore the figure. So let's explain this free body diagram with the expressions. So we have a mass, and we will try to pull to the right side with the Fa applied force and time domain. And according to our initial drawing of free body diagram, we have Fi, which represents the inertial force on the left side. Its expression must be mass times velocity derivative. Then on the left side, we have two more force arrows. The first one is Fb, which is the force exerted by the dashboard. The equation must be dashboard constant times the velocity. And the next one, Fk, the spring force, which is K, spring constant, times the displacement. So we have the detailed expressions and the free body diagram. Now we can skip the black one and we have the model of the system. Then to obtain the mathematical model of the equivalent circuit, the figure, the system, for the mechanical systems, we can apply the D'Alembert law, which is a special version of Newton's force, Newton's second law, and it explains all the forces on a mass must be equal to 0. So if we add all the arrows on the free body diagram according to their directions, our total force must be equal to 0. For example, if we start with Fa, which is our main force, and if we accept the right side for the system as positive, all the other arrows which shows the left side must shown with negative sign. So minus what we have, m v dot, b v, and k x. So this equation must be equal to 0 according to D'Alembert law. Okay, so we have the mathematical equation. But for the modeling side, we want to reorganize the equation according to what? According to inputs and outputs, or state variables and the inputs, outputs can be shown clearly. So for example, for such a system, if we rearrange the equation, we can write mv dot bv and kx must be equal to Fa, which is the applied force, and it is the input of the system. All the system will start with this force, so that means it will be input. And x and v, these are the state variables of the system. With x and v, we can define the parameters of the physical system. Or similarly with this one, we can rewrite the equation with the displacement. So as we know, the displacement derivative will be the velocity. So mx double dot, which is the second derivative of the displacement, and bx dot plus kx must be equal to Fa. So on the left side, we have one unknown parameter, which is the displacement of the system, and it is the smallest variable of the system. So that means it must be one of the state variable of the system. And on the right side, we have the input of the system. So this is the mathematical equation of the given physical system. So we will continue with the block diagram and the simulation of the same system to make a connection between the modeling and the analysis. Thank you for watching.